All right, welcome to the last video for Notes 10, which is going to be on multiplication with radicals. Prior to multiplying with radicals, we've talked about how you can add and subtract radicals. And in order to do that, I'm going to give a couple examples here. Let's say you have 3 root 2 plus, 5 root 2. Because both of these terms have a root 2 in them, you are more than welcome to simply say the root 2 stays root 2. You've got 5 plus 3, that makes 8. Cool, fine, dandy. That is how you add terms with radicals. So if you had, let's say, whoa, that is a horrible 3. Let's try that again. There we go. 3 root 2 plus, 5 root 7. Here's the problem. This root 2 and that root 7 are not like. They cannot be made to be like to each other. So no, you can't actually combine those. Okay? But that's if you are doing addition, or if I could change it to subtraction and be the same idea. Here's the thing. Multiplication, whole different ballgame. You can multiply anything. It doesn't matter that this is a root 2 and that's a root 3. You can absolutely multiply them together. So you just simply multiply 2 times 3 makes 6. Now, can you break up a root 6 using a perfect square? Absolutely not. And if you think about the numbers, right, the 2 here and the 3 here, there'd be no pairs of numbers that we could use to simplify that. So that is simply going to stay root 6. All right. Now let's move on to, I'm going to slide this up, notes 8, try again. Problem 8, we're still multiplying. Root 6 times root 2, well, 6 times 2 makes 12. Cool. Let's see if we can simplify it. I will use the prime factorization method here, so let's go ahead and break this up. And it doesn't matter what you use to break up the 12. Let's say I use 2 and 6, because, well, if you think about it, that's how we multiplied them together. Cool, we can do that. 2 is a dead end, right? Can't do anything with that. I don't need the color palette. 6 is 2 times 3. So 2 is another dead end, 3 is a dead end. So the square root of 12 could be rewritten as 2 times 2 times 3, little multiplication dots in there. And hey, look, we have a pair of 2's. So when you do this, the pair comes out front, right? That single 2 represents the pair of 2's under the radical. And then you've got root 3. So starting from the top, root 6 times root 2 became root 12. We did the work then to simplify root 12, and root 12 can be rewritten, simplified into 2 root 3. Okay, so that is the idea behind multiplication. But wait, what happens now when you've got a coefficient in front? How do you deal with that? Well, again, you're going to multiply what you can. So we're going to take the 3 times the 4, and then separately, we'll take root 2 times root 9, okay? So taking it apart in pieces, 3 times 4 makes 12, and then root 2 times root 9 is root 18. If we want to go with the perfect squares, we can do that again, or I'm going to do it again. We could do the perfect square method, or we could do prime factorization. I'll do prime factors. And let's say for this one, I say, oh, well, 3 times 6 is 18. Absolutely correct. 3 is a dead end. 6 can be broken up into 2 times 3. There's another pair, set of dead ends here and here. So how do I write this? All right, well, there's my 12. 18 is 2, 3, and 3. Okay, so where's my pair? I've got a pair of 3's. So that means that's going to be 12 times the pair of 3's. One of them comes out front. Root 2 stays that. All right, finish it up. So 12 times 3 makes 36 root 2. We did a lot of work here, but that's everything. Okay, so starting at the top, we multiplied coefficient times coefficient, root times root. We got 12 root 18. Root 18 gets broken up. That becomes 3 root 2, and then we can multiply that with the 12. All right, as always, let me know if you have any questions or concerns, and I'll see you in the next video.